Today I discuss one important topics related to pseudo inverse and system of linear equation. Okay, pseudo inverse and system of linear equation. System of linear equation. Okay, also known about this topics, also known about pseudo inverse, definition of pseudo inverse in previous class. Today we also discuss in this way. Let A be an M cross N, be an M cross N matrix. We know about that one matrix with entries from some field F. Okay, with entries in F. Okay, in F. Then what happened? Then for every B belongs to Fm. Okay, the matrix equation. The matrix equation Ax equal to B is a system of linear equation. Is a system of linear equation. Okay, is a system of linear equations, and so it either has no solution, so it either has no solution. Okay, a unique solution, or infinitely many solutions, or infinitely many solutions. Understood? Then what happened? That means we also known about that a system of equation has in this way some solution. Okay, now we write it in this way. System has a unique solution. Okay, system has a unique solution. When unique solutions exist, unique solutions for every v, unique solutions for every v belongs to Fm. Okay, when these solutions exist, we now erase our portion and going to discussion about that. Okay, when this solution exists, that means A is if and only if and only if A be invertible. Okay, A be invertible, then these solutions exist. Now we're also going to discussion in this way. That means if A is invertible, in which A inverse and the solution is given by the solution be what? Solution be A inverse B. Okay, and in this way, if A is invertible, then what happened? Then A dagger equal to A inverse. We know about that. Okay, then solution can be written as what? A dagger B. Understood? Not a problem at all. So we're also now going to discussion about that. A is non-invertible, then the system is inconsistent. We know about that. Okay, we know about what? If A is not invertible. Okay, if A is not invertible, then what happened? Then we also write it in this way. Then okay, system be inconsistent. System be inconsistent. Okay, understood? System B inconsistent. That means solutions are not exist, but then A dagger B also exist. Understood? That means A dagger B, we can find this one. Okay, but here solutions are not exist. Okay, is then what we relate by this one. Okay, A dagger B related to the system of equations. Well, so now here the factor A dagger B is related to the system ax equal to b. Yes, this one is the question mark now. Okay, we now discuss this one today. We first discuss one lemma related to lemma on this topic. So we erase that portion and going to further discussion one lemma related to that topics. Okay, so we start from this lemma. Okay, I write it now. Lemma, let v and w be finite dimensional inner product spaces. Finite dimensional, okay, inner product spaces. Then what happened? And let dv to w be linear. Okay, then what happened? Then first one is t dagger t. Okay, is orthogonal projection. Okay, it's orthogonal projection of v on anti-perpendicular. Okay, and b here t dagger is the orthogonal okay projection of w on rt. Okay, we now discuss the proof of this lemma now. So this one is so simple. T dagger t is orthogonal projection of v on anti-perpendicular. Okay, now we discuss this one first. Okay, so we write proof here and going to discussion of this proof now. Here we define what? We define L equal to, known about that anti-perp to RT. This one is defined by Lx equal to Tx. Okay, for all x belongs to anti-perp. Okay, then next what happen is here, if x belongs to this anti-perp, okay, then what happened? Then t dagger t x equal to what? T dagger t x equal to, t dagger means what? L inverse L x. Okay, equal to what? Equal to x. Understood? Now we'll also write it in this way. We erase that portion and going to further discussion of that. So we write it in this way. If x belongs to nt, then what happens? Then t dagger t x equal to what? T dagger of 0, okay, equal to 0. Then what we get? We get this way, this one, t dagger t x equal to, here x, if x belongs to anti-perp, and 0 if x belongs to anti. So what happen is here, then we write it. So consequently three dagger t, okay, is the orthogonal projection of V, is the orthogonal projection of V, okay, on NT far perpendicular. Understood? I think all are understood this one. Now we're going to discussion another one. Okay, that means what this one is, we write it now in this way. B three dagger T three dagger. Okay, here that means L equal to what? L equal to NT perpendicular to W. Okay, and Lx equal to Tx. Now we write it in this way. If x belongs to Rt, okay, then what happened? Then 3 dagger x equal to what? Equal to, we know about that. If x equal to Rt, then 3 dagger t equal to L inverse x equal to x. Okay, and if x belongs to Rt path, okay, then what happened? If L belongs to Rt path, then here t dagger x equal to what? Here we write t of 0, okay, equal to 0. Understood? So this one is written as in this way. T dagger, okay, t dagger x equal to x if x belongs to Rt, and 0 if x belongs to Rt path. Okay, so what we write now? We write in this way that this one, okay, we write in this way. What? Here t dagger is the orthogonal projection of W on Rt. Understood? Not a problem at all. Okay, now we're also going to discussion one theorem. Okay, so we erase that portion and write the statement of this theorem now. Here we write this theorem. Consider the system of linear equation Ax equal to b. Consider the system of linear equations. Okay, system of linear equations Ax equal to b. Okay, where A is an M cross N matrix, where A is an M cross N matrix, okay, and B belongs to Fm, and B belongs to Fm, okay. Then what happened is here, then we write it in this way. If x equal to A dagger B, okay, then x has the following property. Then x has the following, okay, following properties. First one, A, okay, we write it in this way. If Ax equal to B consistent, if Ax equal to B is consistent, is consistent, okay, then Z is the unique solution. Then Z is the unique solution. Unique solution. Okay. To the system. To the system having minimum norm. Having minimum norm. Okay. That is what, if ax equal to b is consistent, then Z is the unique solution to the system having minimum norm, and that is Z is a solution to the system. Z is a solution to the system. Okay, Z is a solution to the system, and if y be any solution, y be any solution, okay, to the system, then what happened? Then norm of Z less than equal to norm of y, okay, with equality if and only if, with equality if and only if Z equal to y. Understood? Now we're going to discussion another one. We write it B, option B. Okay, that means if A is equal to B consistent, then Z is the unique solution to the system having minimum norm, and Z, in this way we write it, Z is the solution to the system, and obviously y be any solution to the system, then norm of Z less than equal to norm of y with equality if and only if Z equal to y. Okay, understood? Then again, if ax equal to b is inconsistent, okay, then what happens? Then Z is the unique, okay, Z is the unique best approximation to a solution. Z is the unique best approximation to the solution. Okay, Z is the unique approximation to a solution having minimum norm. To a solution having minimum norm. Okay, understood? That is, in this way, that is here norm of ax difference b less than equal to norm of ay difference b, okay, for any y belongs to Fn, for any y belongs to Fn. Understood? With equality if and only if, with equality if and only if ax equal to y. Here az we write, then this one is beta. Okay, that means ax equal to b is inconsistent, so z is the unique, then az. Okay, then az equal to ay, and if ax equal to, if az equal to ay, furthermore, okay, furthermore if az equal to ay, then what happened? Furthermore, if az equal to ay, okay, then norm of z less than equal to norm of y. Okay, with equality, if and only if, with equality if and only if here z equal to y. Understood? Now we're going to discussion proof of that theorem. Now we start proof. We also understood this theorem and how this A dagger B is connected to the system of linear equation. Now we write proof here. Okay. For convenience, here T equal to LA. Okay. Let this one. Then what happened? First, suppose that AX equal to B is consistent and let Z equal to A dagger B. Okay. Now observe that what B belongs to RT. Okay, and therefore AZ equal to A dagger B equal to T dagger B. Okay, equal to B. Understood? Then what happened? Then Z is a solution to the system. Then Z is a solution to the system. Okay. Now we write it in this way. Now suppose that y is any solution. Now suppose that y is any solution to the system. Okay, suppose that y is any solution to the system. Then what happened? Then T dagger Ty equal to what? Equal to A dagger Ay. Equal to what? Equal to A dagger B. Equal to what? Equal to here Z. Understood? And hence Z is the orthogonal projection of y. Z is the orthogonal projection of y. Okay. Z is the orthogonal projection of y on NT path. Understood? Now therefore, so we write it in this way. So what? So if we, that means discuss this way, that means if y be any solution, okay, then what happened? Then norm of Z is then equal to norm of y. Okay. So we also discuss this one now. Okay, how this one is happened. That means we also known about that the vector u is unique to the closest to y. Okay, So in this way this one is done. In this way this one is happen. Okay. Norm z less than equal to pi. Okay. Here then what happened? That means norm of z equal to what? How this one happened? That means we also discuss in this way. Okay. That means y difference, norm y equal to what? Norm y equal to, we write it y plus z minus z. Okay. Y plus z, that means we write it in this way, y difference z plus z. Okay. Then this one equal to what? This one, this square equal to this square, and then what happened? This one equal to y difference z square plus norm of z square. Okay. Since what? That means y difference z. Okay. Here if that means if y be any solutions and z be any solution, then y difference z, that means perpendicular to z. Okay. So in this way we write it here y z and y difference z. Okay. Y z, y difference z. Okay. So we that means write it here. This one obviously what? Greater equal to norm of z square. Okay. So we will write it that this one. Understood? Not a problem at all. So we also done this one. That means we write what? This one happened. Okay. And with equality we also known about that. With equality here z equal to y. Understood? Now we're going to discussion, that means proof of option B. Which one? Suppose that ax equal to b is inconsistent. Ax equal to b is inconsistent. Okay. Then what happened? Then by the lemma, okay, we discuss it, this lemma. By the lemma, what happened? We talk about that az equal to what? A of a dagger b equal to t of t dagger b equal to what? Equal to b. Understood? Is the orthogonal projection of b on rt. Okay, we know about that. This one is the orthogonal projection. Okay, this one is the orthogonal projection of b on rt. Okay. Therefore what happened? Therefore az is the vector in rt. Therefore az is the vector in rt, is the vector in rt. Okay, nearest b, nearest b. Okay. Then what happened? We now erase that portion and going to further discussion of that. Okay, here that is if ay is any other vector in Rt. Ay is any other vector in Rt. Okay, then what happened? Then here Az difference P less than equal to ay difference B. Okay, similar way we also discuss this one with equality if and only with equality if and only if what happen? Az equal to ay. Okay, then finally we suppose that, okay, finally suppose that y is any vector in Fn. Y is any vector in Fn. Okay, such that what? Such that Az equal to ay equal to C. Understood? Then what happened? Then A dagger C equal to here A dagger Az equal to what? A dagger A, here A dagger B equal to what? Equal to A dagger B equal to Z. Okay, then what happened? Then we also see that means Ax equal to C to conclude that here norm Z less than equal to norm Y with inequality if and only if Z equal to Y. Okay, that means here we apply this one and part A of this theorem to the system Ax equal to C. Okay, and then what happened? Then we also see that norm Z less than equal to norm Y. Okay, that means we apply what? We apply part A of this theorem. Part A of this theorem. Okay, because Z equal to A dagger C, here Z equal to A dagger B is we considered, but here we considered Z equal to A dagger C. Then what happened? Then part A of this theorem to the system what? To the system Ax equal to here B not B, C, because A dagger C equal to Z. Then what happened? Then we conclude that similar way norm Z less than equal to norm Y if and only if. Okay, if and only if Z equal to Y. Understood? Not a problem at all. So we also discuss this theorem easily. Okay, the consequent lemma theorem we also discuss easily. So today I stop here. If you get this type of video, please subscribe my channel. If you have any questions, comments, suggestions, write it in comment box. If you want to give like, please click on like options. Thank you.